Good morning, my dear students. Let's continue with correlation. So, Carl-Pearson's correlation we have seen. Pearson's correlation, coefficient of correlation, Rxy, which we simply write as R, is given by covariance xy, sigma x, sigma y. First we'll do it when we have no frequency involved. When there is no frequency, it becomes summation xy divided by n minus summation x divided by n, summation y divided by n. The whole thing divided by sigma x is nothing but standard deviation of summation x squared divided by n. You got to be careful with this. Summations and so on. Summations of x and summations of x squared, they are not the same. Summation y squared divided by n minus summation y divided by n, the whole square. The square comes right up to here. Right. This is Carl-Pearson's. As I said, when there is you expect a logical, when there is a logical support and a good strong value, positive or negative, we can use it for writing down the regression lines, which we will come to a little later, but let's see how to calculate these values. When the data is small, there's not much, there is no much difficulty, but this is the formula that you will have to remember. When there is no frequency, if there is frequency, the formula will be different and we will do problems with frequency a little later. The formula changes a little bit here and there, but now we are doing it for the time being for very small data sets, which normally we don't encounter such small data sets when we in practice we want to calculate anything involving statistical inquiry. Any statistical entity normally requires data sets to be pretty large, because small sets do not tell you much about the big population. So, compute for the bivariate data given below, compute the Carl-Pearson's coefficient of correlation. So the data that is given is x and y. And as I said, this is not really a big data, so it's not, generally you will not see data like this, so small, but this is just for our calculation purpose. This is all that is given. There is no frequency, sometimes there are frequencies involved, and that we will see later. This is all that is given, this is the problem, and when you want to solve, you always remember the formula. Once you know what is the formula, summation xy divided by n minus summation x divided by n into summation y divided by n divided by square root of summation x squared divided by n minus summation x divided by n, the whole square. Of course, there are two formulas for this, that they are exactly the same, because you can prove that. This is summation y divided by n, the whole square. I hope that it's not too congested there. So, we require summation x. N is equal to 3. 1 to 3 pairs of data. And this is 6, and summation y is equal to 9. And then you require x into y. You require x square. You look at what is required there. That's all that you need. You already have an n. What you don't have is you have x, so you take summation x. You have next is you want to do summation xy. You require that. You require summation x square. It's there, summation y square, and that's about it. Nothing more you would need. This becomes 3, this becomes 2, this becomes 15, so this becomes 20. This becomes x square is 1, 4, 9. This becomes equal to 14. And this becomes 9, 1, 25. And that becomes equal to how much is that? 35? Yes, it is. So what is R going to look like? Let's substitute and calculate. So substitute and calculate. You know R is actually a covariance xy divided by sigma x, sigma y. And sigma x is this, sigma y is that, and covariance is that. So basically, it will change when the frequency comes, and there is another formula for writing this. But we'll look at it later. So what you get is, here is summation x into y is 20 divided by 3 minus, this is 6 divided by 3 into 9 divided by 3, and then you have square root of x square, that's 14 divided by 3 minus 6 divided by 3, the whole square equals square root of, what will you have? You will have 35, I guess 35, yeah, divided by 3 minus, you will have 9 divided by 3, the whole square. So can you simplify this? Well, you can. Let me wipe. I'll wipe off this much because I'm going to use the second formula to solve the same problem. And this R becomes equal to now. So this is 20 by 3 minus this becomes 2 and that becomes 3, so it becomes 6, I guess. Yes, it is. 6 by 1. Here you will have square root of, you have 14 by 3 minus, that's 2 square, that's 4 by 1. You have 35 by 3 minus, you have 9 by 1. I hope you are getting, because when you cancel this, you get 3, and 3 square is 9. So finally you get R equal to, the numerator becomes 6 is 18, so 20 minus 18. 20 minus 18 divided by 3, you have square root of, I should not be doing all these simple calculations for you, 14 minus 12 by 3, and this is 35 minus 27 by 3. Well, this root 3 into root 3 will give you 3, and this 3 will get cancelled, and so your R is going to look like, what is your R going to look like? Well, your R is going to be something like 2 divided by, you get root 2 into root 35 minus 27. How much is that today? Yes, it is. So that becomes 2 root 2, 2 times root 2. I guess this is going to be something like 1 by 2. That's 0.5. So R is equal to 0.5. That's weak positive correlation between x and y. Well, there is another way to prove this. There is another formula for this, and we will show that these things are actually equal. R can be also written, covariance can be written as summation x minus x bar, y minus y bar divided by n, and the whole thing divided by square root of summation x minus x bar, the whole square, divided by n, into square root of summation y minus y bar, the whole square, the whole thing divided by n. And let's do this. N is 3. What is x bar? X bar is summation x divided by n, which is 6 divided by 3, which is 2. What is y bar? Y bar will be summation y divided by n, which is summation y is 9 divided by 3, which is 3. So if you have x minus x bar as one column, if you have x x bar is 1 over. And you have y minus y bar is 1 over. And then I'll write this formula again. We'll show that they are equal actually. And then you have x minus x bar square. And then you have y minus y bar square. Oh, you could have directly done that. And then also you have x minus x bar into y minus y bar. This is all that you need because I have wiped out the formula, but let me rewrite the formula. This is all that you need in that formula. What is that formula that we have written? Summation x minus x bar, y minus y bar divided by n and divided by, what do we have? What do we have here? We have summation x minus x bar the whole square divided by n, square root of summation y minus y bar the whole square divided by n. Well, actually we don't even have to write that n. You can simply write this as summation x minus x bar, y minus y bar divided by square root of, summation x minus x bar square, and you might be tempted, summation y minus y bar square, you may be tempted to cancel out square and square root, you can't do it. Of course, if you have x square and then square root, you can cancel, but if you have x square plus x1 square and x2 square, now you cannot. So that's what is happening. There's a summation there. So that's what is happening. So you got to be careful. You might be tempted to cancel this 2 and this square root. It's a blunder. If you know x minus x bar is actually x minus 2. So you give you minus 1. Give you 0, 1. Y minus y bar is 3. Give you 0, minus 2, 2. This square will give you 1, 0, 1. That will give you 0, 4, 4. And this into this will give you 0. And this into this will give you 0 again. And this into this will give you 2. Therefore, what you will get? R out to be? R will be equal to. You see, you have to write summation. This is what I require. Summation x minus x bar the whole square. That becomes equal to 2. Summation y minus y bar the whole square, that becomes equal to 8. Summation x minus x bar into y minus y bar is 2. So what you are left with is you get a 2 on top, you get a square root of 2 here, and you get a square root of 8 there. It's exactly 8.5. It's exactly the same value because the formulas look different, but they are exactly the same. Okay, let me do one more calculation for you and then one more calculation. And you don't have to, if you are asked to solve, you don't have to use both formulas. You just use one of the formulas that you prefer, first or the second. And we'll show that they are equal and so on. Let me give you another problem based on some simple values again. This kind of data you normally will not get in practice. In reality, you get data which are little large, or both in terms of the values will be large and also the data set will be large. And so often people do these things on programs. There are softwares. You just feed in the data and you get all your interpretations, all your statistical values and interpretations, everything comes ready-made. So again, find Karl Pearson's, it's the same thing. Exercise is compute Karl Pearson's. Coefficient of correlation on the following data. Bivariate data. Bivariate data. There are two variables. It's not a single variable data. So we are calculating the correlation. So, by the first formula, So let me use both the formulas. And by the first formula, R is equal to summation x1 divided by n minus summation x n summation y divided by n. Please write down the formulas correctly. I hope they are visible to you, but the formulas have to be written correctly. This is summation x square divided by n minus summation x divided by n the whole square. And the other one is summation y square divided by n minus summation y divided by n the whole square. So these formulas are very important. This is one formula, and therefore n here is equal to 4. That is just the number of pairs that are given. And summation x is going to be how much is this going to be? 10. Yes, it looks like. Summation y is going to be how much is that going to be? That's 10 and 20 is that 30. Yes, it is. What is x square going to be? What is, we require y square and we require x into y. If you look at this formula, that's all that you need. There's nothing more. This formula, that's all that you need. That's all that you need. X square is going to be 1, 4, 9, 16. Well, this summation x square is going to be the same as this sum, that's 30. Summation y square is going to be 1, 16, 81. This is 256. I don't know how much that is going to be. You have, how much is that going to be? You have 82, 16, that gives you 8, 9, and plus 2, 5, 6, that gives you 14, and 15, and 3, 354? 354, okay. And x into y is going to give you 1, it is going to give you 8, it's going to 9, 3 is 27, and 16 goes like 64. What is this summation? So this is summation y square, and I hope I have not made any mistakes here. I am very good in making mistakes. That's my forte. Okay, so you have 28 plus 28 is 36 plus you have 64, and that's going to be 100, right? So this summation xy is going to be 100. Wow. So therefore R is going to be, you have 100 here, divided by 4, minus you have summation x, that's 10 divided by 4, your summation y, that's 30 divided by 4, right? Of course, right. And what do you have down below? Down below you have something like summation x square, that is 30 divided by 4, minus you have 10 divided by 4, whole square, and then you have square root, another square root here, summation y square is 354. 354 divided by 4, minus you have 30 divided by 4, the whole square. Right. So this is what we have. And that can be calculated. So R is going to be equal to 400 minus, this is 400 minus 300 divided by 16, I guess. The numerator, just see the simple calculations. You have something like, you get 100 by 16, and you get 120 minus 100 by 16. I hope for my calculations you can see. Okay, and square root of, multiply by 4 here, 16, carry on 5 is 20, 21, carry 2, and 4 is 12, 12 plus 2 is 14, divided by minus, that's 900 divided by 16. Well, that's 16, root 16 becomes 16, goes out, so R becomes equal to, what will you get? R becomes equal to, what will be R? R will be 100 divided by root of 20 into root of, well, that's 516, I guess. see what calculation I have done. That finally turns out to be R becomes equal to 100 divided by root of 10320, and that's going to be 100 divided by 101.59, and that's going to be 0.9843. That becomes the answer. If you do it the other way around, using the other formula, you should get exactly the same answer. Of course, if you truncate somewhere things, then okay. So if you use the other formula, it should be, what should happen is the other formula is simply becomes like last time. Simply becomes summation x minus x bar y minus y bar divided by square root of summation x minus x bar square divided by summation y minus y bar square. Generally, the first formula is easier to calculate, I think. So I have ignored n because there was a divided by n here, there was a divided by n, but there is also divided by n and it goes off. And as I said, you must take care, you can't cancel square and square here. That care you have to take. What is x bar? X bar is summation x divided by n, that becomes 10 divided by 4, that becomes 2.5. What is y bar? Y bar is summation y divided by n, that becomes 30 divided by 4, that becomes 50 divided by 2, that's 7.5. I suppose, right? Yes, it is. So x minus x bar, that's 2.5, and y minus y bar, that's 7.5. Well, what will you get then? This will involve some fractions, so it's not going to be very nice, but you can do it. This will be minus 0.5, this will be 0.5, and this will be 1.5. And when you subtract 7.5, you get minus 6.5, minus 3.5, you get 2.5, and you will get something like, yes boss, you will get something like okay, is that 8.5? That's right. And you will have to do x minus 2.5 square, you will have to do y minus 7.5 square, and you will have one more column, and that column is nothing but x minus 2.5 into y minus 7.5. Now this involves a lot of calculation, and I think I should leave it to you and see that the answer that you get eventually, when you substitute, you must get the same answer as what I have done by the previous method. You substitute these values, this value, these values into this summation x minus x bar, y minus y bar, this guy into this square root of summation x minus x bar. When you get here, you get summation x minus x bar square, that is summation y minus y bar square, that this is summation x minus x bar into y minus y bar. Please do these calculations. Substitute, plug it in here. Summation y minus y bar. The answer should be exactly. So the answer should be exactly equal. There could be a little difference in case some truncation somewhere. If you do some truncation, there might be a small truncating error. But otherwise, the formulas are exactly the same. And okay, let me show why they are exactly the same. And these are very small values of variables we have taken. And also the table was, the data set was small. Both of which usually will not be small. Okay, My point now is sigma x is written as, you see, summation x minus x bar square divided by n, and I am saying it is the same as square root of summation x square divided by n minus summation x divided by n whole square. These two are same. Well, that's not difficult to show. If you want to show that, okay, just show that this expression and this expression is same. Those two expressions are same. And so solution is quite simple. It is enough to show that summation x minus x bar square divided by n is the same as this. So if you take the left hand side, we want to show this summation x square by n. So to show that, you want to show this. Well, you take the left hand side. This is summation x minus x bar square divided by n. Well, that's going to be nothing but, remember, this is going to be xi actually, but we don't write that just to make life simple. This is a constant, this is a constant. Mean is a constant. This guy is not, this guy is a variable. And that's what is summed, right? So this is summation x square minus 2 times x bar plus x bar square. The whole thing divided by n. So that becomes, you know, summation can be, so if you have summation of xi plus yi, you can write it as summation xi plus summation yi. That's not the case with multiplication. I mean, you cannot write summation xi into yi as summation xi multiplied by summation of yi. This you cannot write. This is not correct, but this is correct. Okay, so I can write this as summation x square divided by n minus, here I get 2 times summation. You see this x bar can be brought out, so I can write 2 times summation x bar. X cannot be brought out because it's summing x divided by n. Constant can be brought out, summation. You see this x square, x bar square can be brought out. What it will remain is 1 divided by n. And when you are summing up n times, 1 is summed up n times, you get an n here. So this becomes summation x square divided by n. This becomes x bar minus 2 times x bar square. This becomes n gets cancelled, so x bar square. And this finally becomes summation x square divided by n minus x bar square. Well, this is exactly the right hand side. Why? Because x bar is, this is x bar. This guy is x bar. Because x bar is summation x divided by n, and therefore x bar square should be summation x divided by n the whole square. So this expression is exactly the same as this. That's the right hand side. You start with left hand side, you come to right hand side. So this formula that is given, sigma x like this, or it is given like this, they are the same. Same thing happens with sigma y. I am not going to show that, but covariance. You see, covariance also, the two formulas are the same. They are not difficult to prove. This is very easy things if you just take care with summations. So if you want to show summation x minus x bar into y minus y bar divided by n, I want to show is summation x into y divided by n minus summation x divided by n into summation y divided by n. And don't forget, this is x bar and this is y bar. Don't forget that. I want to show this. And what you do is you take the left hand side. Solution. Take the left hand side is this guy, which becomes this chap is left hand side, which becomes, when you multiply, you get xy, you multiply x there, you get minus x times y bar, multiply this here, you get minus x bar times y, multiply this with this, becomes plus x bar y bar, this whole thing divided by n. And as I said, summation can be spread out, multiplication no. Not multiplication. So summation can be spread out. So xy divided by n minus y bar is a constant, so summation x divided by n. Here x bar is a constant minus x bar, but summation y divided by n plus you have summation here, so x bar is a constant, y bar is a constant, so summation 1 and that divided by n. But 1 you are adding n times becomes n. When you add 1 n times becomes n. And therefore what you get is this becomes summation x bar divided by n. This becomes x bar, so it is x bar y bar. This becomes x bar y bar, so you get 2 times x bar y bar. This and this are taken together. Plus this becomes n and n goes, you get x bar y bar. So this finally becomes summation x bar divided by n minus x bar y bar, and this is the right hand side. That's the right hand side. So you see, things are pretty simple. They have two different expressions. Even with frequency, we can show that they become equal. But frequency I have not yet taken, right? We'll do that in the end. Because for frequency, the table becomes a little of calculation, becomes a little large. Now you know when you have values of x and values of y are large, not just many but large. So you may have something like 1000 and 1050 and 1100, 1200 and something like that, 1350, something like that. You have big values. Then y becomes, say it takes 100, 120, 100 and whatever, 60, 100 or 200 and 240 and values like this. They are pretty large. So they are pretty large. But what I can do is I can write some other variable. U is equal to, say, I can write x minus, I subtract some value in the middle somewhere, preferably maybe this value. 1000 is the biggest, 1350, somewhere 150, 1100 or 1150 also is okay. Even 1150 is okay, but I just subtract this and I can divide by 50. You must be careful. You want to generally we divide a number that will not give fractions. We avoid fractions because calculation must become simple. So when you put 1000 here, it gives you first value of u. So let me write this on top. I am writing u is equal to x minus 1100 divided by 50. So the first value of u will be under u. First value of u will be, put 1000 here. Put 1000 here. You get 100. That's minus 2. Here 150. 1000. Okay, so that minus 1. Here 1. So here you get a 0. Here you get 100. So it is 2. Here you get, I think. Here you get 250, so that's you get 250 divided by 50, you get 5. I hope things are all right. So these values now I have subtracted. Subtraction actually is called shift of origin, and when you divide, it's called change of origin. Now I'm making this value small because my calculation becomes small. But it's important for me, if I want to calculate x bar, I should be able to calculate from u bar. If I want to calculate sigma x, I should be able to calculate from sigma u. All these things are important, you see. And y, if I write it as v is equal to, say, y minus something, because values of y are large and it goes from 100 to 240, maybe I take something like 160 if I subtract. Somewhere in the middle, somewhere it doesn't have to be 160, even you could subtract 120 or 150 and so on. But somewhere in the middle, and divide by, you can see you can divide by 20, a difference of 20, so that you don't get fractions. And so you would have minus 60 divided by 20 is minus 3, minus 40 divided by minus 2. Then you would have 0. Then you have 40 divided, that's 2. Then you have 40, and here you would have 80 divided by 20. That would be 4. 80 divided by 20 would be 4. Right? Yes, right. So what I am saying now is, now my question is, if I have big numbers and I reduce them by subtracting, which is called shift of origin. Shift of origin is to subtract, and this when you divide is called change of scale. Change of scale. We can divide by anything, but what happens is we divide by some number that is not going to give us fractions. It helps in calculations. You see. Some people may not even subtract, or even divide. They may just do the calculation because you just feed it into machines, or you use a calculator and you can do these things. But if you want to do this thing manually, you would prefer to reduce the size. Even on calculators, if you have big values, it may go out of your screen. So it would be useful to reduce the size. But the point is, if you have B bar, can you calculate Y bar from B bar? Because we are not interested in U and V. Our data is this. So we are not interested in calculations of these values. But the point is, if you have say sigma V, can I come back to sigma Y? Can I come from here to this? 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 And most of all, if you have R U V, can you come to R X Y? Because, and the answer is yes. The answer is yes. Well, we'll see how it changes. So the answer is yes. You divide, you subtract, and we'll see how things change. So we'll see how things change. So calculations become easy. You can calculate those values of corresponding values of standard deviation and from the smaller u and v new variables and come back to the original xy variable. How do you do that? Well, first thing is if x is, or if u is x minus a divided by some c, then x bar is given as c times u bar plus a. How do you show this? If this happens, then this happens. Proof. Very simple. This is given. I have subtracted something, divided by something. So you have x minus a divided by c. So you have multiply here c times u plus bring a this side is equal to x. So you have x is equal to c times u plus a. Put a summation here, therefore you put a summation there. You put a summation on both sides, then divide by n, you divide by n here. And what you get is this becomes x bar. This becomes x bar. What happens to this? This becomes summation, c comes out, it's a constant. U is not a constant. U is not a constant and x is not a constant. These two are variables. Rest everything is a constant. So c times u plus a times summation 1. This is divided by n. This is divided by n. And you can see you have x bar here. And so this part summation u divided by n should be u bar. So you have x bar is equal to u bar times c, and this becomes n, and there is already an n gets cancelled because you are adding this n times 1 n times. You add 1 5 times, you get 5, n times you get n plus 8. So that proves the first one. The second thing is, so that proves the first thing. Second thing is, so you know, if you calculate u bar, immediately from this equation you can calculate x bar. It's as simple as that. Because you know how you have changed u and x. Second thing is, standard deviation sigma x is same as c times sigma u. You see, for the standard deviation, a does not play any role. So, and that proof is very simple because what happens to, you take this, you get x is equal to c times u plus a, and that was an equation by multiply this here, bring a that side. This is the equation that we have got, right? So, what happens? This is the equation we had, and what happens to sigma? What happens to sigma x? Sigma x is square root of summation x square divided by n. Isn't it? Should I use this formula? Yeah, I think. Or should I use? Okay. I'll use the other formula, which says that this is summation x minus x bar square divided by n. This is your sigma, right? And just now we have proved that x bar is c times u bar plus a, and together you get x minus x bar is equal to c times u minus u bar. This minus this, right? Right. So what you get here is square root of summation this x minus x bar square. So you will have x minus x bar square will be c square u minus u bar square. So substitute that x minus x bar becomes c square u minus u bar square divided by n. And that c is a constant which can be brought here and then can be brought here. So c square when it comes out becomes c square root of summation u minus u bar square divided by n. But this is sigma u, so this becomes c times sigma u, and that's the right hand side. And I like to stop here for the time being, so we'll continue next time. Thank you very much.